Good morning, everyone. Let's talk about properties of logarithms. So there are four properties for you to know. First is the product property. Notice if log base b of m times n, that would be equal to log base b of m plus log base b of n. So you can separate this one logarithm into two logarithms and add them. Quotient property deals with division. If you're dividing, so if you have log base b of division, then you can change that into two logarithms and you would subtract those logarithms. Power property says if you're taking the log of a number with a power, that you can actually take this power and you can move it to the front, make that a coefficient of your logarithm. Okay, and then you would have the same base as always of m. Change of base is if for some reason you don't like the base that you are in, you can change that base. We generally change it to common log, which is log base 10, or we'll change it to natural log, which is log base e. In the event that you need to change these, you need to not use the base you're in, you are capable of doing that. So there's three things that we're going to do today. One, we're going to expand. So we're going to use these properties to go from this direction to this direction, expanding one logarithm to multiple. Or we're going to condense, which means to take multiple logarithms, turn them into one logarithm. Or we're going to change the base. Okay, and that's what we're going to work on today. So let's start with expanding. So first, let's expand these logarithms. Okay, so example one. Let's start with something really easy to see. So let's talk about like log base 2 of 3 divided by 7. Now, that is, so let's look at the value of that. So if you go to your TI calculator, notice I have a base of 2. So I'm going to go to math and I'm going to arrow down all the way to option A, which is log base. That way I can put log base 2 of 3 over 7. And that's going to give us this decimal here. So it is an irrational number, a not ending, not repeating decimal, all right? Now I can expand this into two logarithms. This property of division right here allows me to expand this to two logarithms with subtraction. So if I were to expand this, this would be equal to log base 2 of 3 minus log base 2 of 7. And if you go in your calculator, you'll find that that is the exact same value. So if I were to put in, let's see, log base 2 of 3 minus log base 2 of 7, I get the same irrational number. So these two things are equal to each other, all right? Let's see here. Let's say we have log base 2 of 21. Now, if I need to expand this, I need to turn this into multiple logarithms. What I would do is I would rethink this as log base 2 of 3 times 7, because 3 times 7 is 21. And by rethinking it in that way, I can use this product property up here. Log base b of m times n is the same as the addition of these two logarithms. So that would be log base 2 of 3 plus log base 2 of 7. If I have log base 2 of 49, what I'm going to do is I'm going to rethink this as log base 2 of 7 squared. And according to my power property, I can take that power and bring it to the front. So I can make that power into a coefficient now. So that'd be the same thing as 2 log base 2 of 7. Now, when you expand, you're not always just asked to expand with actual numbers. There'll be variables involved as well. So let's look at an example of that. So let's say I have, let's do log base 6 of 3 times x to the power of 4. So this is multiplication, 3 times x to the power of 4. So I know that multiplication can be turned into the addition of 2 logarithms. So I have the addition there. I also know that this exponent can be the coefficient. So that is also equal to log base 6 of 3 plus 4 log base 6 of x. And that would be the expansion of this single logarithm into 2 logarithms. Let's do one with subtraction. Okay, so let's do a natural log of, let's do y over 5x to the 7. Now, natural log, the rules are the same. Notice that these are log base b, so it doesn't matter what the base is. A natural log has a base of e. That doesn't matter to me, the rules are still the same. So this is division, that'll turn into subtraction, so that's the natural log of y minus the natural log of 5x to the 7. Now I'm not finished. I notice there's some multiplication right here, 5 times x to the 7. So I'm going to I'm going to expand this. So I have the natural log of y minus this expansion, the natural log of 5 plus the natural log of x to the 7. I also see that I have an exponent here, and I can move that to be my coefficient. So I have the natural log of y minus the natural log of 5 plus 7 natural log of x. Notice that I kept these together because remember it was the subtraction of all of this. Now at the very, very end, what I want to do is distribute that negative all the way through so that I don't have any parentheses in my final answer. So my final answer would be natural log of y minus the natural log of 5 minus 7 natural log of x. And that would be my full expansion. This would also work for, let's do one with a radical. I think I can squeeze it in here on the bottom, so I'm going to try to. Example 6, let me move this up just a little bit. Okay, so I have, let's do log base 5 of 2 square root of x. Now, the thing to remember is that the square root of x, so remember the square root of x is the same thing as x to the 1/2 power. So I'm going to rewrite this as log base 5 of 2 times x to the 1/2 power. Well, that's 2 times x, so that could be expanded to addition, log base 5 of 2 plus log base 5 of x to the 1/2. This exponent can become a coefficient, so I have log base 5 of 2 plus 1/2 log base 5 of x, and that would be my final expansion. Okay, well, let's look at condensing now. So let's condense some logarithms. Here we go. So we're going to condense to 1 logarithm. I'll just say log for now. We're going to condense these down to 1 logarithm. And I forgot what example number we are on. We are on 7. Okay. Example 7. Let's say I have log of 9 plus 3 log of 2 minus log of 3. Okay, here we go. So that being said, I'm just going to work left to right using the laws. So I see left to right, I have this right here. So I'm going to go ahead and move that up. That way all of my stuff looks like it's just log, log, log. There's no coefficient in the front. So that would be the same thing as log of 9 plus log of 2 to the third power. That's a 3. Minus log of 3. Now I have addition here. Addition is the same thing as multiplication. So that would be the same thing as log of 9 times 2 to the third minus log of 3. And that is subtraction. Subtraction can be condensed to division. So that's the same thing as log of 9 times 2 to the third over 3. Well, cool. So 2 to the third is 8. Let's see, 9 times 8 is, I hate these. Oh yeah, 72. 72 divided by 3 is 24. Awesome. So that's the same thing as the log of 24. This, much more condensed than our original. Let's condense. Let's do something with variables. So let's do something like 4 natural log of x plus 8 natural log of y. I see I have these coefficients, so the first thing I'm going to do is move those coefficients back to the exponent. That's an 8. I don't know what it looks like, but it's an 8. And then after I've done that, I notice I have addition, which can be multiplication. So I have the natural log of x to the 4 times y to the 8. And I've condensed it down to one logarithm. Let's do one more like that. I'll do it to the side so I can get change of base on the same one. Let's do log of x minus log of 9. Y'all, same rules. We have the same base, which is great. You have to have the same base to use these properties, but I have x and then I have minus 9, so that could be condensed into division. So that would be log of x divided by 9. The last thing we need to look at is change of base. So let's change the base. Let's see, example 10. Let's say I have log base 3 of 8. And I want to write in common log. So if I would like this as a common logarithm, I'd have to use change of base. So change of base says what I'm going to do is pick the base that I want. If I'm doing a common log, I want base 10. So I can take this as log of my a value, a, or the answer value, I guess you could call it, divided by the log of the base. Both of these are now log base 10. So I've rewritten log base 3 of 8 as a division of log base 10. You can also do this with natural log. So let's say you have log base 6 of 24, and you need to write this as a natural log. Maybe your problem requires natural logs and you've been given this information as a log base 6, natural log having a base of e. If that were the case, and this happens a lot in real world situations, I can rewrite this as a natural log. So it would be the natural log of 24 divided by the natural log of the base, which is 6. And now I have logarithms written in natural log, and I can do my calculations now in natural log as opposed to log base 6. So that's how you do it.